and are exercised in that manner. That would be wet commissioning. Then you may also hear cold commissioning versus hot commissioning. This would refer more so to the electrical aspects of commissioning, where cold commissioning would be testing systems that are unenergized, and hot commissioning would be testing the system once power is applied and systems are energized. The commissioning phase of the project, in my opinion, is the best part of the project, because this is where you start to see some of the systems function for the first time. This is when you'll discover any issues with the system, and this is where as a commissioning manager or commissioning engineer, you really get involved in troubleshooting the systems and diagnosing the problems as they come up to solve the problems and continue progress of the project. So following commissioning, we then move into plant startup. And this is where the plant processes are started for the first time. Process fluids are introduced and the system starts to function for its intended purpose. Once the system is up and running, then some of the fine tuning of the system can take place. So in the example of a wastewater treatment plant, you're going to introduce process fluids to the systems and start the actual biological processes in the system. When you see these systems up and running is when you can do some of the fine tuning to tweak pump flows or flow rates, pressures, and get that biological process up and running and optimized to the best way that it can proceed. One important aspect that I like to stress during commissioning is operational readiness. So if you're starting with the end in mind, it's important to prepare the owner's operators for continued operation and maintenance of the new systems once placed in service. It's not very fair to hand over new systems to the owner and pass the keys and disappear from site. The operators are looking around wondering what they're supposed to do with these new systems. It's far more advantageous to have the owner's operators involved in the commissioning process and supporting the process to learn and understand the systems, in order that at the end of the project, they're comfortable for continued operation of the new systems. Operational readiness would consist of training of the owner's operators, having all the documentation available that they will need for daily maintenance and operation, like O&M manuals and operating procedures. And like I said earlier, it's best for the owner's operators to participate in the commissioning process. Their input is valuable to determine configuration and operation of the equipment, as well as, to their benefit, have them understanding the processes and systems and asking the equipment experts while they're on site any questions that they have about the systems, so that at the end they're more comfortable operating the equipment. I do like to stress this as a critical part of the project during the commissioning phase, as the commissioning team can help set the operators up for success. With this, then the new facilities are now in service and the project transitions to the warranty phase. The warranty phase can be anything that's defined in the contract, from 1 month to 1 year to 3 years, where the operations team will operate the new systems, and if there are any subsequent defects that arise during the warranty phase, the contractor is required to address those issues for the duration of the warranty phase. So I would like to bring up an opportunity if you'd like to join a free training course. Some of the videos that you saw at the beginning of the session here were clips from the video course, and it's a free course. It's online and it's flexible to take anytime. You can go to commissioningandstartup.com, where you can sign up for the course and take the 3-day course for free. And I hope you do so. It's a very informative course, and we'll provide you some more information on commissioning and startup. And feel free to ask any questions out of that course, or any information you're looking for, and we'll see how we can help you out. So that's a very brief overview of the commissioning and startup process. I hope there was a bunch of questions that came in. I'll answer your questions about any of the information that we discussed and see how we can help you out.
Yes, thank you, Engineer Turner, for a very informative webinar regarding commissioning. So guys, please do not be shy. We still have an ample of time. I think we're given by Janet Turner for about 1.5 hours to have our live question and answer. So anything from the table from you guys, please, you can grab your mic and ask directly our speaker tonight. Or if you are shy, then just write down your question in the chat box. I believe we have somebody here from governments and also private sector, private corporation. I'd like to recognize again civil engineer Maria Teresa Villacorta. We have a very good discussion last night, so maybe she can also ask question. And also the rest of the guys who are new here, don't shy guys. This group is willing to give whatever opportunity regarding the upliftment or enrichment of mechanical engineering, as well as electrical engineering for that matter. We have also PEE in the house. We have good lecturers in the house from APOA. Engineer Ronnie Dagal, maybe you can shoot a question to our speaker, Engineer Paul Turner, Engineer Borja from Philippine Solar Energy Society. Of course, anybody here coming from Philippine Society of Mechanical Engineers, no? And also from IAEE, Integrated Institute of Electrical Engineers. No? So it's now time now to shine, to ask directly our question to Canada professional engineer, at the same time professional project management professional, no? Engineer Turner is here with us. No? So guys, please don't be shy.
Question.
Yeah, recognize the presence of our National Treasurer for Philippine Solar Energy Society, Sir Alvin Orgel. Okay.
Yes, my question, Paul, is when do we test the maximum and minimum of the capacities of the system, and also the fault alarms? Is it in the pre-commissioning stage or in the commissioning stage? Thank you.
Okay, good question. So some of the alarming and control functions would be done during the commissioning phase. During pre-commissioning, that would be energization of the cubicles and making sure that they can communicate with each other. Once we've got the system up and running and communicating is then when we can test some of the finer points like certain alarm triggers or control points. That would be done during commissioning. Now then, the min and max operating parameters of the facility, that would be conducted post-startup. So once the system is running, once the plant processes are up and running, let's use a wastewater treatment plant as an example. There would be minimum flows, say 20 megaliters per day, and then there would be maximum rated flows of 250 megaliters per day. Once the plant is up and running after startup, we could test some of those min and max conditions to ensure that the plant process is going to meet all design parameters, all min and max parameters that were defined in the project. Now, there might be some aspects of maybe related to min and max voltage or min and max temperature. Some of those aspects might be tested during commissioning as well to test some of those extreme points. But the overall, the bigger plant processes would be tested post-startup. So I hope that answers your question.
Yeah, thank you. Yeah, thank you.
Anybody, any more questions, guys? How about Engineer Nograles?
So I do see one in the chat here on what are the basic points in conducting factory testing. So that's a good question as well. Often the manufacturer of the piece of equipment will define what their factory acceptance test plan is. That'll be submitted and reviewed by the project team, particularly by the procurement team and by the commissioning team. The manufacturer is best to determine the points to be testing for their equipment, since they're the experts on that piece of equipment. It will depend on what type of equipment is being tested. Let's take a large oil-filled transformer as an example. So there would be some testing required where the transformer is first energized at rated voltage for a certain duration of time and allowed to thermally stabilize to measure performance of the transformer, measure any off-gassing of the transformer, make sure all the thermal properties are settling out and stabilizing of the unit. There may be some corona discharge measurements. There may be different aspects of some of the control points on the transformer that are measured. It'll be dependent on the type of equipment, but it's a good point to raise, because you'll want to discuss that with the manufacturer prior to proceeding with any of that testing, to see what the manufacturer proposes for tests and ensure that all tests are included in order to confirm all contractual technical requirements as specified in your technical specification. So Red, what I could offer is we could get a little bit more detailed on an electrical commissioning topic. I can pull up a single line diagram and we can review a specific electrical distribution system and kind of the process to commission and start up this electrical distribution system, if you like.
Yeah, you can present it now. You have that with you.
Okay. Hopefully that will spur some more questions as we go through it. Okay, so hopefully you can see the diagram that's up on the screen here. So this is an electrical distribution system, dual redundant, fed off of a 66 kV utility feed from the local utility. All components are redundant and backed up with a diesel genset and UPS systems downstream. We've got a switchgear, MCCs, and panel systems. So I'll briefly go through each component here and kind of the general startup philosophy. So during pre-commissioning, all of these systems would be unenergized, or at least the bus voltages are unenergized. Switchgear would be energized at the control level with the 15 kV bus de-energized and everything subsequent down there. So during pre-commissioning is when you can test a lot of the alarms to the HMI, PLC controls, as well as interlocks of each particular piece of equipment. Once that's completed during pre-commissioning, then you're ready to start up the system. So that would start with some coordinated testing with the utility. The 66 kV feeds, the main disconnects here would be closed to first energize the pair of 10 megavar transformers. These would be large oil-filled transformers, 10 megavars that would step down the 66 kV voltage down to 15 kV voltage. Breakers at the switchgear would remain open in order that the transformers are first energized and allowed to soak for a 24-hour period. This is similar to factory acceptance testing, where now that it's in the field, transformers are energized and allowed to thermally stabilize to confirm there's no thermal hotspots or corona discharge. You likely take a oil sample before energizing and after energizing. You can measure the oil sample to confirm if there's any off-gassing or hotspots within the transformer. That 24-hour soak period is important to confirm that the transformer is operating stable before proceeding with any downstream energization of the systems. So following that 24-hour soak period, you can then close one of the breakers for switchgear 11 to energize this 15 kV bus. In this system, there's a tiebreaker between switchgear 11 and switchgear 12. That tiebreaker would remain open in order that the two utility feeds are closed. Your switchgear would typically have interlocks in the system to guarantee that when the two utility feed breakers are closed, the tiebreaker is interlocked and remains open. Those interlocks would have been tested before energizing from the utility. So that energizes the 15 kV bus of both switchgear 11 and switchgear 12. You typically have a soak period as well, maybe not quite as long as 12 hours or 24 hours, but maybe 2 or 3 hours to confirm that there's no hotspots within the switchgear. Measure voltage, measure current, make sure there's no hotspots in the equipment, then proceed with energizing the downstream electrical systems. So that would include closing the breakers in the switchgear to provide 15 kV power to transformer 13 and transformer 14. These step-down breakers step the 15 kV feed down to 600 volts to energize the 600 volt bus in switchgear 14 and switchgear 15. Similar to the switchgear above, the 15 kV switchgear, the switchgear 600 volt switchgear has a pair of tie breakers as well, and those tie breakers remain open while both the 600 volt bus of 14 and 15 are energized and allowed to soak for a period of time. With everything checking out at that level, then you would proceed down to the next level of commissioning. And this proceeds to 600 volt MCCs. MCCs are motor control centers where they provide the switching, 600 volt switching to panel boards and motor control systems. They sometimes can consist of VFDs, variable frequency drives, to control startup and rotation of electrical equipment. Very similar, there's a tiebreaker there. The two incoming breaker feeds are closed to energize the 600 volt bus of the MCCs, followed by breaker closure of each individual MCC, or could be a breaker, could be a fuse, to each panel board throughout the plant systems. So there would be multiple MCCs throughout the plant process. There might be one set of MCCs in one area of the plant, and then the switchgear feeds another MCC lineup in another area of the plant. From the MCCs, there could often be additional step-down transformers to provide 208, 120 volts, or 240 volts, whatever voltage is required in the country that you're operating in, to provide power to the various panel distribution boards throughout the plant. Now, a few other aspects of this system are at the 600 volt level. We have these high frequency filters. These are harmonic filters that stabilize the 600 volt power as equipment is being switched in and out. There can be spurious voltage levels on the systems, and these filters help to stabilize that power to keep it consistent and stable. We also have a UPS, an uninterruptible power supply, that is fed from 600 volts normally. Should that 600 volt feed disappear due to disruption to the utility power, the UPS can continue powering particular panel boards, ones that would be considered essential loads, for a period of time, not indefinitely, but depending on the battery capacity, for a duration of time, to continue powering those essential loads. As you're energizing the UPS and doing some of the testing there, you're going to want to do a battery discharge test to confirm that the batteries meet the capacity requirements in your technical specification, and that would consist of connecting a load bank to the batteries and watching the discharge profile of the battery bank to confirm that it lasts the duration, expected duration as defined in your contract. So back up here at the top, I also mentioned that we have a diesel genset backup. We have a pair of 2 megawatt diesel gensets, and these would not normally be left off and on standby in case there should be a disruption to the 66 kV power. So let's consider the scenario that one of the 66 kV voltage feeds is disrupted, and the utility no longer provides that power to the system. In that case, the incoming breaker to switchgear 12 would be open, and you can continue powering the entire plant off the second 66 kV feed by closing that tie breaker of the switchgear. That would energize the entire 15 kV bus off of the 166 kV feed. But should the situation present itself that both 66 kV feeds from the utility are disrupted, that's when the diesel gensets come into play. So they would be configured with an automatic switching sequence that senses the loss of the 15 kV bus in the switchgear and automatically energizes the diesel genset and closes the breakers with the interlock systems to provide power to the 15 kV bus. Typically, the automation system would then energize only the essential loads, since it's unlikely that the diesel gensets can power the entire plant. They can likely only power a particular subset of essential loads. The automation system would start to switch in those essential loads as required. Now we also have a 2 megawatt static load bank here. Given that the diesel you seem to be getting some feedback there.
This is coming from the market.
Any way we can mute that?
So guys, can you please mute yourself? Okay, wala na. I think
Okay, that sounds better. Okay, so I was discussing the static load, the 2 megawatt static load here. Typically, the gensets don't run very often. Ideally, they never run, but you do want to verify that they are capable to run when needed. So periodically, monthly, weekly, whatever your maintenance schedule determines, we can connect each genset to the 2 megawatt static load and run it for a period of time at full load to confirm that the genset is ready to run when it's required. So if we think about the basic systemization of this system, it could be broken down into a few different aspects here. I would consider the gensets as one mechanical completion, one turnover of the system, separate from the rest of the system. That package with the static load could be defined as one mechanical completion for that scope of work, and defining the physical equipment that's required, listed by tag number, as well as the documentation required for that turnover, that mechanical completion. I would then consider the basic electrical distribution to energize up to the 15 kV system and 600 volt system as another mechanical completion. That essentially gets the basics of the system up and running to be able to provide power throughout the plant. Then I would probably consider each plant area specific as a separate mechanical completion as well. So the pair of either 15 kV or 600 volt cables from the plant power systems over to the plant area specific MCC and panel board systems as another separate mechanical completion, given that the rest of the plant is likely phased and coming online in various stages. You could split the power to each of those areas as separate mechanical completion, given that power may not be required in one area as early as required in another particular area. So that's a brief overview of a particular electrical system. Hope that helps, and hope that has spurred some questions. If there's anything that you'd like to know, please ask your questions.
Yes, do we have any participants here who have related, experience regarding the, electrical systems? Engineer Turner, this electrical systems is what kind of project is this? We have a wording of hydro, 66 kV.
Yeah, so in Canada where I am, a lot of the power is produced by hydroelectric generating stations. So this would be hydroelectric power from a 66 kV feed. That doesn't necessarily, it's not always the case for sure. That could be nuclear, that could be wind, solar, coal plant, could be anything that's providing that 66 kV feed.
Okay, maybe our solar professional here, Engineer Alvin, can give us sharing on electrical systems if he's um, recipient on this or have some background on this when solar generation can reach up to 66 kV. But I don't believe we have only have up to 160 megawatts. The 160 megawatts can only produce about 66 kV, 160 megawatts. In 160 megawatts produce a 66 kV, or it goes down to a low voltage like 220 volts or medium voltage or like a switch gear. When you input that to on grade, now you go to on grade to our national grid, um, wherein there's net metering. The net metering, you're going to sell your solar output to the power grid. So I'm not sure, quite sure if how it's to be done in regard to kV, 600 volts, whether there's a conversion coming from your, residence when you're putting up as a residence, but at the same time you're putting it into commercial later on. You're going to sell a power, a solar output by way of net metering grid. Do you have a net metering grid for solar, Engineer Turner, in your area?
Yes, typically in Manitoba, where I'm at here, we're very big on HVDC power. We have some very big rivers in northern Manitoba where 70% of the power is generated. Problem is, it's at the wrong end of the province. All the population is at the bottom end of the province. So that hydroelectric power in the north would typically be converted would be produced at 15 kV, but then we step that up to 230 kilovolt systems for AC distribution. But because 70% of the power is up north, we also have 3 huge HVDC links that transmit 70% of the power down south to the other end of the province. Through those HVDC links, that's transmitted as 500 kilovolts DC. Still, all that power in the north is surplus to what Manitoba's needs are, and a lot of that power is available for export sales to neighboring provinces and neighboring countries. So it does depend on the configuration of your system. Typically, the generation of wind or solar or hydro would be generated at a lower AC or DC voltage, but then for long distance transmission, AC transmission would be stepped up to a higher voltage, say 138 kV or 230 kV through transmission of AC systems. And then in the case of HVDC transmission, that's typically where if you're transmitting longer distances than longer than 600 kilometers, it becomes more economic to transmit by DC as opposed to AC. And when you get into that DC transmission, then a converter station at either end of the line to convert to, in Manitoba's case, bipolar transmission of plus and minus 500 kilovolts DC.
So
So I do see another question on, do you use software coordination during commissioning of transformers? So during design, during analysis of some of the results, certainly different softwares are used from a design perspective for simulating HVDC stability control functions and those types of aspects, those detailed PhD studies of dynamic performance of some of the electrical systems. Definitely there would be some complex software packages required there. I'm assuming that your question refers to software specific to the commissioning process. And I've used various different types of software, but never found anything that's really all that industry standard on what's commonly used throughout the systems. The biggest thing seems to be information management and document management, because there's a pile of information that's produced during commissioning, and you need to have a process to be able to gather that information, decipher that information, and distribute it to others on the project that need to know that information in an expedited manner, given that commissioning is moving pretty quickly and everybody needs current information at their fingertips. So I've used mostly document management systems to be able to receive and transmit those documents and ensure that all stakeholders on the project have the information that they need. I've never found a particular piece of software specific to commissioning that that I've used that is overly helpful, but there's always new systems that are being produced and being available, and I'm aware of some that are being developed kind of as we speak, and hopefully a lot of those software packages are further development to help with the information that's available during commissioning, because the information available continues to grow and will continue to grow, and we do need to find better ways, more current ways to handle the information, process the information in order to make sense of the large data sets that are available from commissioning.
Anyone want to raise a question? Engineer Nograles, can you state a question regarding our topic tonight with Engineer Turner? Anybody?
Fred, can you hear me?
Yes.
Fred,
Of course.
just a clarification. Regarding that diagram ba? What that diagram ba rin, that schematic diagram?
Yes.
Yep.
What is the advantage or
Yes, you can.
the 1500
I don't think I caught the question there. It was a little bit cut out.
Yeah, we'll allow him to come back. We can have able to come up with a good signal. I think he's using a mobile phone right now, but essentially he can manage to go out with his question.
For sure, yeah. Or maybe type it in the chat there so that we can get your question answered for you.
Engineer Nograles, can you also write down if you have some problem, technical problem, then maybe later on we allow you to come back with your question. So we have a question from the chat box. Can we answer that?
Yes, there's a question in the chat box. I also send on WhatsApp, Paul.
Okay, so the question I have is for the wet commissioning, say piping systems conveying cooling water and compressed air, what's the usual procedure in flushing the system and pressure testing? And this question is from David. So let's start with fluids first for water. for flushing of the system, typically in its permanent installed configuration, there would be a pump that's driving water through piping, say to one of the plant processes. So the discharge of that particular piping may be going to a tank or somewhere downstream for further processing of the fluids. Now we may have to do a temporary configuration just to flush the pipes. So during the construction, prior to actually making that permanent connection to the final tank, the discharge of that pipe may be routed to somewhere external where the fluids can be captured, so that any debris of the system that's coming through there isn't ending up in downstream plant processes. But without that final connection being made, then the permanent pump can be used to run fluids through the permanent piping for a period of time. This can flush out any debris, any construction debris that was in there. That can typically work. That doesn't necessarily always be the case. If there's valving or particular obstacles in the pipe, when you're flushing it, you may encounter some of those obstacles. I've seen, you can see some strange things that are in piping when you're doing flushing in certain areas. There are wildlife of systems maybe that have sat for a period of time. There's wildlife in the pumps. There's a bunch of snakes or something, or you can find shovels or lumber, anything in the pipes. There's the strangest things can show up in there, rags and overalls, coveralls, who knows. You can expect anything that's in there while piping's being installed. So a lot of that stuff should flush out. If it's debris like gravel or something, then that will flush out. If you get some really large debris, then maybe the permanent pump and permanent pipe won't be sufficient. But when you encounter those items, you'll have to troubleshoot them and take apart the pipe or something to get those items out of there. But typically the permanent pipe, the permanent pump could be used for that flushing process. If that's not the case, maybe you don't have power available yet to run that permanent pump, then you may need a temporary pumping system to apply water, apply pressure through the piping to run them for a period of time to flush out the systems. Then with regards to pressure testing of fluids, say for a fire sprinkler system, this would be done in a similar manner with the heads of the fire suppression system removed. You would flush the pipes to make sure that there's no debris in the system. Once flushing is complete and you got all little grains of sand and everything out of there, that the permanent heads of the fire suppression system can be installed. You definitely want to do that flushing, because the smallest little piece of debris can clog the fire suppression heads, and you don't want that to be the case, that your fire suppression system is failing you when it's actually needed during an emergency. So with the fire heads then installed and the piping system completely closed off, the piping can be charged with a pressure and left for a period of time, say 3 days, to measure if there's any pressure drop. There will typically be some nominal pressure drop, but as long as it's within standards or your technical specification, that pressure holds over a certain period of time, then that would confirm that the piping has been leak tested and pressure tested in the case of fluids. In the case of air, it's very similar. You would potentially flush the systems out with a liquid, depending on your technical specification, but you would flush them out with air at the very least to confirm that there's no debris in your compressed air lines, and then close off the system by installing permanent tanks and permanent valves to pressurize the air lines and monitor the pressure drop over a period of time to confirm that pressure drop is within your technical specifications. So I hope that answers your question, David.
Thank you, sir.
Yeah. Any more questions, guys? I'd like to shoot a follow-up question on that related sprinkler, if you may allow. What standard are you using in Canada, for that matter, regarding sprinkler? What standard?
For fire systems, we in Canada, we typically refer to an NFPA. I don't remember the specific NFPA number, but I would have known them at some point, but the various NFPA standards would apply.
It's okay, Engineer Turner. We're using the same standard. So I'm just trying to point out to everyone here that in the Philippines, we're also using NEPE standard out of our local standard. If our local standard cannot give and provide specific, practices or requirement, we go to the NEPE standard. So another question, Engineer Turner, regarding the standard for hydro testing. What standard are you using? That Canada or another international standard in particular?
With regards to flushing and leak testing, typically it would be contract specific requirements. So NFPA, of course, but then any additional contract or technical specification requirements would be typically what we would use in Canada.
Okay, do you have any other questions, guys? So while you are sorting out your question, maybe I can ask again. Engineer,
For sure.
Engineer, we have already Engineer Nogales smiling. Maybe he's ready now with this question. Engineer Nogales, please shoot out your question, the one unfinished question that you have. Please don't hold or forever will be lost or forever. Please, yeah.
Hello. Hello.
Yeah.
Hello.
Yes, we hear you.
Can you hear?
Yeah. Please.
Yeah, just one clarification
Yes.
about the main bus of that schematic diagram, the 15,000 bus and the 600 bus.
Yep.
It has, what is the advantage of double tiebreaker on the bus? Double tiebreaker in tandem.
Okay, let me pull that up here again.
The question goes like, what is the advantage of having a double,
Tiebreaker.
tiebreaker?
So I think you're referring to, say, the difference between the tie between switchgear 11 and 12 and the double tie between switchgear 14 and 15.
Yes.
There.
Yes.
So I'm not aware of any particular advantage other than just redundancy in the system. If it may depend on the particular interlock design of the system as well. It may also depend on the specific vendor equipment that was used here. I can't recall the specific model or vendor switchgear that was used in this application, but if the standard equipment comes with a default tiebreaker at one end of the bus, then maybe you end up with two of them.
Okay. So there is, depending on the requirement of the owner or the design.
That's correct. Yeah, maybe it was specified as a hard spec requirement for a specific piece of gear, which would therefore mean that you end up with two ties there. If it's more of a performance specification where it could be more generic to any vendor or manufacturer's piece of equipment, you may not necessarily end up with two of them. It would depend on maybe how it was specified during the procurement phase.
Okay, thank you very much, Mr. Paul.
You're welcome.
So during the pre-commissioning stage, Engineer Paul, the SGR 11 and 12 will already be satisfied, no? And before going to commissioning, the SGR 11 and 12 must be tested first to avoid the problems in the future going to the commissioning stage, so that pre-commissioning will already satisfy the system's overall performance, right?
That's correct. Yeah, during the pre-commissioning, you're going to want to check out that breakers can be racked in and out, that any remote operation or control from the PLC or HMI systems can control each of the breakers, that you're getting the correct statuses of each of the breakers back on the HMI system. You're going to want to verify during pre-commissioning any of the interlocks to confirm that when one breaker is closed, a particular breaker is open, and that's critically important from a safety perspective, that all those interlocks are checked in advance. All of these functionality checks, you're going to want to confirm prior to applying 15 kV to that bus, so that you know that the system is going to function correctly before you have high voltage applied to the main bus of the switchgear.
Maybe we can throw the question to Engineer Nograles. Our typical systems in the Philippines maybe utilize 66 kilovolts down to 22 kilovolts, sometimes 34, 33 kilovolts, down to 440 volts at the medium voltage. Does that necessarily be a good comparison to Canada electrical system? Do we have any problems having that configuration? We don't have the same configuration as you have right now. Your 15 kV might be, in our side, can be 21 to 22 kV down to 440 volts or 380 volts. What can you say about that, Engineer August Nograles?
We have, in the Philippines, we have standard voltages. So in Canada, they have another standard voltages. So we follow only the Philippines system.
Yeah, but I'm trying to relate now with Engineer Paul. If this kind of systems that we are following now is already a systematized system, coming from what source or coming from what reference code, I believe it has already been proven for a while. So there's nothing wrong about that. But just right now, looking at this diagram, it's also another diagram from Canada. So I'm just trying to state here if everything is workable, whether you are coming
Yes.
from 50 kV or 600 voltage, so it's workable. There's nothing wrong with any voltage at all.
Yeah, nothing, everything is possible. We have here in the Philippines, we have 66,000 volts. We have 21,000 volts, and we have also 440 volts. So it depends on the requirements.
Yep, it would vary across different parts of the world. For example, in Canada, we have typical household voltage is 120 volts, 60 hertz, but I know that's not the case everywhere. Typically, elsewhere in the world could have 240 volts and 50 hertz.
Correct.
Yeah, I don't know how come you have asked that question, the advantage of tiebreaker. We see a lot of tiebreakers in our line diagram. How do you be able to come up with that proposal, Engineer Nograles? Why do you ask that question?
This is just a redundancy of the system.
Okay.
It can be one only tiebreaker, or it can be two tiebreakers in tandem, depending on your purpose. If it is redundancy, then it can be done by one tiebreaker only.
Okay.
Yes, it can be one, but they have a specific purpose for this, just to satisfy their needs.
Yeah, at least everyone understands the main point while we are presenting that diagram. So it's just a matter of presenting the
Yes.
hydro systems that we have right now. But for your information, Engineer Paul, I don't think we have reached that kind of capacity to produce that kind of electrical voltage for that matter for our hydro. I think we have only a minimal hydro capacity. Am I correct, Engineer Nograles, with regards to hydro? So we cannot depend really on a hydro system regarding our renewable energy. If we are looking at providing an independent power resource in our area. So might as well look for another renewable energy resource like solar system. Are you independent of solar system in your area, Engineer Turner, or mainly to produce in terms of hydro or coal? You have also coal in your area or at or nuclear energy system?
So typically, because we have abundance of hydroelectric power, 95% of the power generated where I am here is generated hydroelectrically. We do have 2 wind farms in Manitoba here, but they're not cost competitive to hydroelectric generation yet, because in Manitoba here we have one of the lowest hydro rates in North America because we have an abundance of hydroelectric power. So there are some smaller solar installations. There's the 2 smaller wind installations, but hydroelectric dominates all of our power in Manitoba. That's not the case in all parts of Canada. Manitoba has a lot of water resources because it's all passing through the province towards the Hudson's Bay and into the ocean. In other parts of Canada, there is more nuclear generation, there is more wind and solar generation. And in areas to the west, there's still reliance on coal generation. Just recently, with the last project I worked on, with the 3rd bipole that we put in service, allowed Manitoba to retire the last coal plants that we had in service here. So there's no more coal power generation in Manitoba, but in the west, in Saskatchewan, Alberta, and BC, there is still a higher reliance on coal generation.
Okay, what you're saying, guys, they mainly rely now on hydroelectric, but though there is still an ongoing operation of coal, but later on maybe phase out, and some areas doing coal. Because of that, maybe you have also that policy of the state, just like anybody is going to phase out coal at any rate, just to phase out the coal, utilization is thereby a harmful to the environment, providing a greenhouse effect or greenhouse warming effect. No? And I think the main reason why they are very strict on the utilization of coal. So thank you for that information, Engineer Turner, regarding coal. So guys, do you have any more questions relevant to your field? If you have any concerns about commissioning process, not just for energy, power, or another field like wastewater, or if you want to talk about NASA and aerospace, Engineer Turner has also relevant experience on that in that per se. No, Engineer August, can you also, Engineer Borja, can you share your, Engineer Marvin, Engineer Rodolfo, Engineer Sir Alvin, Engineer Mosen, Manuel, don't be shy, guys. No, this is now the time to ask questions relevant to whatever technical field that you are right now. I have already asked my lead Engineer Turner about the windmill, about the solar. So that's all of that. And about the electrical system, I think it's discussed already by Engineer Nograles. I think somehow we know what are the electrical system, applications in applied by Engineer Turner. So Engineer Turner, you are not only working or consulting for Canada, but you can also do some work on other places in other countries, right? You can do consulting whenever your professional expertise can be applied. You can help also, especially the Philippines. They are banning or gearing for build programs and electrical, applications, even to the point of having a nuclear energy in the future. Maybe somehow your expertise can help in the field, no? Nuclear energy. We are trying to build a nuclear energy. I know that you've heard a lot about the energy plans for the Philippines. Do you have heard something about Engineer Turner, about our plans to move for energy nuclear programs or implementation in the Philippines? And what can you say about nuclear implementation?
So yeah, I specialize in anything commissioning related, typically higher level planning and systemization of a project related to development of the project commissioning plan and overall schedule and sequence of how to execute commissioning. Essentially anything related to the commissioning process, starting early on in the project to final handover to the owner. That's been my experience over the last several years, is leading and planning the overall commissioning process. Now, I'm not as familiar with Philippines initiatives and transition of power generation. What would be the largest portion of how power is provided in the Philippines currently?
Yeah, we have a lot of mixed energy in the country. Number one is more on coal. No? Also, the next will be diesel and another number of energy resource like windmill, solar, hydro. But in the future, we need a lot of energy, conversion. That's why we are resorting to nuclear energy program. So may I hear from you, Engineer Turner? We have a lot of disastrous and catastrophic events happening with nuclear application, not just in Europe, but also in other Asian countries, Chernobyl, in Japan, and even the 3 Mile Island in US, who has been devastated by this nuclear. And I believe also that in the current trend in the newest industry technology, there are already efficient nuclear facilities or uh, systems or technology that is now being brought by Russian technology, which are we are now beaming towards for the solution of our power energy deficits. So that's what we are going to right now. Hopefully, maybe you can share to us your viewpoints on energy programs or any application. A lot of American American experts in the field of nuclear already cited the the positive aspect, no, the advantages of nuclear, despite of all the negative, precedents. Can you see what is your thought? What is your favor? What is your stand about nuclear energy, Paul Turner?
So any types of those environmentally friendly power generation methods are certainly a good initiative. I'm not sure if the Philippines has set some power policy to transition off of coal, but certainly if the resources are available for hydroelectric generation, solar, wind, as well as nuclear, those all seem to be systems that countries are progressing towards. You hear some of the initiatives from some of the European countries to transition off of any coal dependence prior to 2030. You hear about a lot of large corporations in the world, Apple and Microsoft and Facebook, to be carbon neutral and to be entirely powered off of renewable sources of power. So this definitely seems to be a huge trend in the world to transition to any of those types of power generation systems. And it's exciting when you hear companies like Tesla that are developing power walls and home power systems to power locally. There's definitely seems to be a trend to comment on nuclear that maybe a lot of the centralized power distribution systems are or generation systems are more so going to transition to a distributed network where you're going to be generating power more locally as opposed to requiring huge power plants and large transmission networks to bring the power to your house. The technology definitely seems to be evolving down more to the distribution level and the local generation level to have distributed generation. And if the technology can further develop and the systems can evolve down to that distribution level, that can potentially open up huge opportunities for power generation, as well as huge technologies for powering the systems that we depend on for transportation, for generation of power for industries, as well as for residential systems. So I also see another question in the chat window here is, Paul, what was your worst commissioning experience and how did you cope with such situation? And this question is from Harold. So commissioning definitely can present all sorts of challenges. Typically, there's two types of challenges that are encountered during commissioning, are the technical challenges as well as the people challenges. The technical challenges can always be resolved. There's often no technical problem that can't be overcome. Often the more difficult ones, unfortunately, are the people challenges. When you're working on huge projects with big teams, there's lots of people, lots of personalities, and as part of commissioning, you definitely need to be a good communicator because there's lots of stakeholders and lots of competing priorities, and that's probably the most important role of the commissioning manager, is to manage and control all of those stakeholder expectations so that you can proceed through commissioning appropriately. Often when there's competing priorities, that's what can get in some of the way of being successful in making progress on the project. So it's very important for the commissioning team to get involved early in the project to help set some of those expectations, manage some of those expectations to minimize some of those personnel issues. From a technical perspective, what was some of the worst commissioning experience just from a technical perspective? There's always minor issues of when you're energizing something, you've got a protection device polarity backwards and you trip off a unit right at the beginning when it's first being energized. Those issues are typically pretty minor and can be addressed so that you can proceed with energization. Some of the maybe more technical issues that we found can be quite costly and add lots of delays to the project. If you find fundamental problems with rotating equipment, often those can be quite long to address and expensive to address. I'll maybe give an example of particular PLC logic and code. It's like I talked about for factory acceptance testing, it's critically important to test all of your logic and code in advance before testing on the real systems. What happened was during testing of a large synchronous condenser, the PLC code, the contractor was late and was rushing development of the code, and it wasn't thoroughly developed and thoroughly tested appropriately. So while this large machine was spinning, the PLC code did not transfer oil pumps correctly and shut one of them down, therefore wiping a bearing on a synchronous condenser. And that was a 3 or 4 month delay to pull that unit apart and replace the bearing in there. to reassemble it, to only get back to where we were to start and continue testing the PLC logic and correct that deficiency so that the oil pumps correctly feed oil to the bearings and don't wipe the bearing during that particular fault scenario. That would be an example of a very costly mistake and delay to the project to address issues like that.
Okay,
Thank
Engineer
you.
Harold, maybe you are going to throw a question, please.
Thank you, Engineer Paul, for such experience, and how did you keep up with that? Anyway, supposing, let's say, during the commissioning process in the fire protection system, supposing there's a problem with regards to the, what you call this, the pressure requirement. Maybe perhaps pressure requirement was not able to attain during the commissioning process. How did you, were you able to experience such things, and how did you solve such problem, such scenario?
Yes, that's a good example. I recently did experience that a few months ago. Typically, those types of mechanical pre-commissioning activities are best done by the construction team. So the pressure and leak testing of the particular fire system required a bit of setup, because when you're pressure testing and leak testing the piping, it was actually over pressurized to a certain I forget the technical requirement, maybe 1.5 times rated pressure. So that could only be done over the weekend when there was nobody operating or testing in that area. So the test was set up to start on a Friday evening and take place over the weekend, and monitoring pressures when everybody returned, or during the weekend, and over onto Monday when everybody returned back to site. And it was discovered that there was leakage in the system. So it's a bit more involved, because then to troubleshoot that and to diagnose where the issues are can take place to some regard while we're proceeding with other commissioning activities in those areas Monday to Friday, but then are hopefully addressed to redo the test again on the Friday over the weekend again. So the leaks were discovered and fixed by the construction team, and that's why I say it's best for them to do those pre-commissioning activities, because if there are leaks, then they're the ones that are best to address those leaks and redo fittings or welds or whatever's required to make the system hold pressure. Then the test was redone again the following weekend, and sure enough, there was still leaks. And again, the week after, we had to, or the construction team had to identify where are the leaks and hopefully address them. By the third weekend, it was able to hold nominal pressure over the weekend, that the leak rate was per specified requirements, and the minimum pressure was still obtained by Monday when everybody had returned for another week's worth of work. So something as simple as a leak like that took 3 weeks to address and can cause lots of delays in the project. So you typically want to do a lot of this testing as early as you can to find even the little problems, so that they don't cause bigger problems when you actually need that fire system during, say, first energization of one of the systems.
Yeah, any additional question? I'm so happy that you have brought up that kind of question, because, maybe everybody has experienced that even a little tear drop in the joints of your fire protection can already substantial, and disapproval of your, commissioning. Whenever the clients saw a tear drop, a very small drop of your joints, in every piping system. So that already accounts to non-approval of your. You have to really remove and backlash that and rework on that, so that it will not result to leaking in the further stage of your testing. So that's how meticulous or tedious a commissioning process, no? that relevant to our contracting works, or if you are in the construction as a main contractor or subcontractor. So I really felt on that. Thank you so much for citing that kind of scenario about the pressure that is not attained. Probably you'll change the main device, the pump itself. It's not meeting the pressure. Somewhere along the way, there's a big pressure drop, so you need to make some flexibility on the other end to increase the pressure, residual requirement, so to meet the standard or the design pressure, meeting or exceeding the client's requirement. So thank you for sprinkler situations. Any more applicable, topics or question, Engineer Borja, that we can say to our speaker, Engineer Paul Turner?
Actually, it's a great pleasure for us here in the Philippines that we do have speakers such as Engineer Paul Turner to share with us his experiences. And perhaps if ever any one of us can encounter such problem here, in the actual workplace, at least we do have already the idea on how to somehow cope up such scenario, same as Engineer Paul had done. Thank you very much, Engineer Paul, for your wonderful or very good advice for us. Thank you.
You're welcome. Yep, happy to help.
Engineer Turner, in part of your commissioning acceptance for wastewater, are you referring to the EPA standards or the quality levels of wastewater? What do you call these conditions as per EPA or your country's monitoring compliance requirement?
Yes, for sure. Yeah, EPA does play into it for sure. The environmental license requirements are set at a provincial level, coordinated amongst the plant I'm working on and all other plants in the system. In the way that we're structured here, there's a large river that's running from the south to the north that is quite common for cities along that river to use for discharge from their wastewater treatment plants. So it's definitely coordinated at a provincial level, and in this case, between countries, to confirm that environmental requirements for ammonia discharge and nitrogen discharge into the river are within certain guideline levels, because they're all feeding into the same lake and eventually the same Hudson's Bay system. So the plant I'm working on was built 40 years ago under different environmental requirements, which is why we're undergoing a plant upgrade at this point, because provincial environmental requirements are certainly a lot more strict, and more ammonia needs to be removed from the current biological process. So that's the standards that we're working towards, are the provincial license requirements set out by the province that certainly refer to EPA standards and other standards to coordinate the permitted discharge into the environment, and therefore what this plant needs to meet.
Right. So may we know also, Engineer Turner, what type of wastewater systems classification that you are using? Is it SBR? Is it the traditional wastewater type of treatment? Is it activated sludge system, or the latest technology like the MBBR, or whatever process that you may have right now?
So
maybe
the current
particular to our application here in the Philippines.
So the current biological process that is being conducted at the plant is an HPO system. I believe that's a high pressure it's an oxygen system, but not it doesn't remove phosphorus to the levels that the new process will entail. So it's being the new process is being upgraded to a BNR process, which is more stringent and a better biological process with better chemical treatment to remove more phosphorus from the wastewater. So I'm not necessarily the process expert, but it is an activated sludge process where through aeration, chemical treatment, and biological growth through a few different tanks in the system can remove a larger portion of the phosphorus from the systems. The activated sludge is returned from secondary clarifiers into the biological tanks and then fermented on site for a period of time to reduce ammonia and phosphorus from the systems before any of the thickened sludge is removed from site.
Yes, I understand perfectly. BNR is all about biological nutrient removal, and it's a additional, process being included to upgrade the system. May I ask, Engineer Turner, the construction team that you are talking about are mainly responsible for all this, or they are a third-party team that might come in order to undergo and then undertake the commissioning process? Is that a third party or is still part of the commissioning construction team?
So the construction team members are certainly one participant in the commissioning team, but the commissioning team would then also be made up of the process experts that understand the biological process and have designed and specified the biological process, as well as the owners, participants, contractors, participants, vendors, manufacturers, participants that form the commissioning team, the overall commissioning team that forms the group of experts to pre-commission, commission, and start up these biological processes.
Okay. So that's great. So you are the one heading the commissioning team, Engineer Turner, and hopefully that project will be, commissioned and this year, or what is the time frame for that project that you are doing? How long is the project? Um, time frame or schedule?
So certain aspects of the project will be started up still this summer before it gets too cold. Seasonal constraints are definitely a concern in Canada, in Manitoba. When we get down to minus 40 degrees Celsius, a lot of the outdoor water processes have to be up and running so that they're not going to go below freezing. So some of those processes will be started up still this summer season before we get into the cold season. Other aspects of the system will still be started up next summer once we get through some more of the construction activities over this next winter period.
Okay, that's a good. Maybe Engineer Turner can help us on wastewater. There are a lot of wastewater, and Engineer Villacorta is no longer here. He's doing a lot of wastewater for compliance to government requirement. We have here also a PEE, a professional electrical engineer. At the same time, PME, Engineer Nograles, and a professional mechanical engineer, Engineer Borja, and PEE, Engineer Ruel Bibero. Maybe you can shoot another question, Engineer Bibero. Or we have one question at the chat box.
I think we've covered all the questions in the chat box, but certainly submit any more. If there is any more questions, we'll get them answered.
What is your worst commissioning experience? Engineer Tonel, do you have any worst?
Yeah, that one we discussed a bit earlier with related to the wiping of the bearing.
Ah, okay. So perhaps other discipline like architecture can have also commissioning, but I'm not sure architecture commissioning. We have here from the buildings, chief engineer. For solar, they have also commissioning. Engineer Nilsson, one of our senior here. Kento, do you have any question relevant to our topic tonight? Joy?
No, I don't have any questions, but I appreciate the topics that we have today. It's
Thank
great.
you.
It's
Thank
great,
you.
really.
About Newell Daniel, Manuel Kirby, Engineer Joy, Queenie, David Rins. Please don't be shy because it's our opportunity to ask Engineer Turner. And Engineer Turner is not coming from Philippines. He's just from Canada. So maybe we'll take advantage of asking him about what's best or goodness of our engineering systems, not just for technology, or whatever engineering applications you are facing now. You can now raise a question to, or civil engineering aspect. You can ask. Maybe he can relate. He can choose some advice about the 3-day package. Engineer Turner, we just want to clarify is that there will be a fee or that will be free package for everyone who have attended now, or still we have to pay on that to enjoy that 3 days package about the commissioning, processes.
For sure, yeah. So the 3-day mini course that I offer is free to anyone that would like to join. It's free and flexible to take anytime. You can get started and sign up at commissioningandstartup.com. Following that, then there are some paid options if you're looking for more in-depth training. I have a mechanical commissioning course that you'll be offered after completion of the 3-day mini course, as well as I'm working on a detailed electrical commissioning course that hopefully will be available within the next month. So those are upgraded options that are available after you take the free 3-day mini course if someone would like to pursue commissioning in a little bit more depth.
I have two remaining question, Engineer Turner, regarding reliability of the system. Which phase the reliability requirements would come in? Is that during the pre-commissioning or commissioning stage? Reliability part of the system.
So that's a good point. Often in contracts, it can be specified performance guarantees that could be reliability being one of the minimum performance requirements. So in some of the past projects that I've worked on, once the system is in service during the warranty period, the performance guarantee period runs in parallel. So it may be stated that you need 99% availability, and that's monitored over, say, a 1 or 3 year period during the performance guarantee period to measure the actual real-time availability, reliability of the system. There can be commercial implications of meeting those performance guarantees or not. If it's specified that 99% reliability is required and the system achieves 99.5% reliability, well then the contractor has met their performance guarantee requirements and therefore gets payout of those commercial funds attributed to that parameter. But if the system is plagued with issues and is tripping off all the time and isn't available 99% of the time, is maybe only available 60% of the time, well then there's commercial implications in that as well, as the contractor hasn't met their performance guarantee requirements for reliability and therefore doesn't achieve the commercial portion of that payout related to that particular performance guarantee. So there can be a few different types of performance guarantees that are specified, one of them being reliability, another one being losses of the system. If the systems can only achieve, say, need to perform at 97% efficiency but are not meeting that, then that could be another performance guarantee requirement that's specified in the contract during that performance guarantee period.
Yeah, the second question, Engineer Turner, which part of the phase where the acceptance of the national electricity grid will comment uh, um, what stage it will comment and how it is accepted, the acceptance or the supply of the national grid. For example, the incoming supply, power supply going to the plant. So where is that stage where it coming from?
Another good question, and that can be done in stages too, because you do need connection to the electrical grid at some point to further commissioning. So it can get tricky when you're connecting not fully tested systems to the bulk electric grid, and you have to because you need to commission the systems, that you need to ensure certain protocols are in place that the not fully tested system is not going to impact in-service assets elsewhere in the system. So it's very important during the commissioning phase that that's a very structured and organized process, coordinated with the central control operators to make sure that there are no impacts on the system. So it wouldn't necessarily be when it's first connected to the bulk electric system, because the system's not fully commissioned, but that would be the first point of impact to existing assets that are in service. Then there may be a period of time, could be weeks, could be months, where the systems are further checked out before you can deem the system ready for commercial operation, where it's fully handed over to central control operators and it's under their care, custody, and control and jurisdiction for operation of the new assets. At that point in time, when the commissioning manager, the commissioning team signs off on the system and says, yes, this meets technical requirements and is ready for commercial service, that would be the point in time, I would say, when it's handed over and in central control systems, care, custody, and control for operation and coordination of those assets with other assets within the bulk electric system.
Okay. So my last final question, Engineer Turner, is we're talking about commissioning process. So overall, after all, careful, compliant, and meeting all the specification, what are other things that should be met by the contractors or the general contractors in order that the client will finally and fully approve the commissioning process? That's the end of the contract, Engineer Turner.
So one thing that's often forgot about is all the documentation. The physical assets are one thing, that they are built and installed to the quality level that's required, and that the commissioning team has tested everything and it functions to the technical requirements. But one thing that's often forgot about is the documentation, and that's a critical aspect for the owner. Is they need to have an accurate set of drawings at the end of the process. They need to have all the O&M manuals, all the information that they would need for continued operation and maintenance of the system, as well as to be able to troubleshoot the system should there be issues once the project is complete. Once the project team leaves, then that resource isn't available, and that's all they've got is to count on the documentation. So in 2, 5, 10 years or 20 years after the project is complete, the documentation is critically important for future operators to know the system, understand the system, troubleshoot the system so it can operate for the life of its intended duration. So the documentation is critically important, and often the contractor, nobody likes documentation, nobody wants to do all the paperwork, but it is critically important to have a very structured and organized process to gather that information and have it available for the operating team for years to come.
Okay, guys, I think that's the time is now 9:46. So if you have already, satisfied with our speaker, do you have more question, Engineer Nogales, in your mind? Engineer Vivero?
Wala na, wala na.
Wala na ba?
Wala, no more.
Yeah, Harold, wala na.
Yeah,
I have a lot of
I,
time, but I'm very sorry. I need to also understand Engineer Turner. Maybe more questions coming from me. We would say that ano ba tong taong to? Daming namang tanong. So I'm just giving time for you guys to ask questions. That those are just very important questions that we need to raise. Of course, Engineer Turner, in parting, what can you tell our audience, our participants regarding commissioning system?
So the point that I raised earlier is that you need to start with the end in mind. You really need to think about commissioning as the process to pull the project together at the end, but that thought process needs to start right at the beginning of the project. If you can start with the end in mind, then your project's going to be much better set up for success. I've seen projects where commissioning is an afterthought, and at the end they're trying to find, well, how do we make the system work? Let's get some commissioning people here and try and figure this out. And that's always a scramble. It never works well. So you need to start with the end in mind and have commissioning in the front of your mind early in the project in order to set the project up for success.
yes.
I would encourage anyone to that would like some more information on commissioning to sign up for my 3-day mini course. It's free, and you can check it out and get some more information on commissioning. And certainly if there are any questions in the future that you have related to commissioning, reach out to me and I'll see how I can help. You can find me at commissioningandstartup.com.
Yeah, thank you very much, Mr. Turner. Thank you very much for sharing your knowledge and experience to us.
Thanks, everyone. Happy to contribute.
Yeah, thank you. Thank you so much, Engineer Turner, and hope we can have another session. More progressive and more technical discussion regarding the field of engineering, and hopefully this will not be the final thing and the end, but this will just be the beginning of our continuous relationship, especially for the Filipino engineers. Thank you for your time. Thank you for granting us our request that you can be here with us tonight. Although not everybody here are present, but hopefully we can invite more participants in the future, and we can deliver more engineering expertise to these people. So thank you again, Engineer Paul Turner from Canada, guys. So that's it, guys. So see you around.
Thanks, everyone. Have a great day.
Dr. Raj, can you ask our
Thank
engineer,
you.
professionalized industrial engineer, maybe Dr. Raj can raise question to our Engineer Turner?
No,
Wala na?
wala na.
Are you intimidated by our speaker, Engineer Turner?
No. Thank you so much.
This will be your last piece to
Very
ask.
good. No, it's a very good discussion.
Very good. Can you show yourself? Show yourself.
Ayoko.
What happened to yourself? What happened? Okay, we will not prevent or hold our. Oh, that's Dr. Raj. Okay. You have any question before we
No,
start,
I don't have any.
Engineer Turner? Relevant to any field? Taxation. Engineering. Media. Whatever field. Commissioning.
Maybe next time. I have much more for hookup and commissioning.
Next time, okay.
Yeah, it's more on offshore engineering.
Bye-bye, guys. Thank you,
Yeah.
everyone.
Thank you
All
so
right,
much.
everyone.
Thank
Have a good day.
all.
Bye, everyone.
Thank you very much.
So
Bye.
you can
Thank you.
give
Thank
the
you.
email ad of
Thank you.
Engineer Paul Turner in the chat box, that everybody can directly communicate with them. Yeah, there's a need. So maybe you can write down your guys. Note the email ad of Engineer Turner in the chat box so you can write down directly your queries to him. I know I have a email ad, but you can go directly to him if you wish to. So maybe he can add on that. So Engineer Turner is writing down his email ad. You can directly email him whatever concern that you need for him to, you know. Okay. So good night, everybody. Thank you again for coming and listening to our webinar. Thank you to our great speaker, no, Engineer Paul Turner, and he and her supporting, Miss Mary Ann, uh, Miss Mary Ann Ermani from Singapore. Are you from Singapore, ma'am? Philippines. Philippines, eh? No, from Malaysia. From the Philippines. Okay. Malaysia. Then Philippines. Okay. So the email ad of Engineer Turner is support at commissioningandstartup.com. Okay. Yeah, you can connect him to him right away. So thank you, everyone. See you around. See you tomorrow for another webinar. Just stay tuned to our Facebook. We have another webinar tomorrow and the rest of the days. No, don't worry. We'll invite again Engineer Turner if he's willing and able and free for the next time. He will always be there for us, guys, for the Philippines. Thank you, everyone.
Bye.
Thanks, everyone.
Bye.
Bye.
Beer muna tayo. Beer. Tus.
Okay, bye-bye.
Eh,
Yeah.
wala na. Ah.